sorry. I'm going to take 5 minutes to set this up, but it's probably going to be worth it. I discovered something yesterday that I thought was super cool, and I want to share it with you. This is, what is it? Arch Linux, yeah? So our next guest is Torsten, come all the way from Finland. He's a very interesting person, as you might have noticed from his shirt yesterday, certainly. He's also got a very interesting talk. You guys read the title. It's about compiling Ruby down to a single executable. Maybe we do this some other time. But I discovered yesterday that in Finland, there is a Finnish Bhangra band, and they do all your favorite Bhangra tracks, but in Finnish. So it was very awesome. I think they can be used very much for international diplomacy between Finland and Canada someday. Okay. Cool. Welcome, Torsten. And do you have your bio in your slides?
Do I have what?
A biography or introduction about you?
Yeah.
Okay, yeah. Super. He's a hobbyist Ruby programmer today, which is
a luxury.
Which is interesting.
Yeah. Okay, this is, yeah. So hi, everybody. That's the talk I'm going to have. Just a little bit about me. My name is Torsten. I don't do social networks so well, but you can find me on GitHub under Ruby Design. And I've been coding for a while professionally also, and I have the good fortune of doing it as a hobby nowadays. So I'm from Finland. I don't know. This is a picture of people making a hole in the ice and going swimming into it. That's sort of. Just wanted to share that with you, how weird things get up there in the north, and don't judge me for the rest. What's coming? I run a bed and breakfast with my wife in Finland. That up there is the sun, yes, in winter. We were here before 2 years ago. That's my wife, Raisa in the back. Okay, but about the project, it's really very simple. It's compiling Ruby to binary. I'm actually surprised this hasn't been done before. But the twist here is a little bit. It's 100% in Ruby, so there's no C involved whatsoever. No libc, no C compiler or nothing. Unfortunately, 20 minutes is a great length for a talk, but it's not going to be enough to go into any depth, so I'll sort of just show you a little bit how it's supposed to do things. So I fell in love at first sight with Ruby in 2001. At the time, I was still doing Java. And actually, even before I learned about object orientation, programming C++ too, and I read a lot about Smalltalk. How many people here know Smalltalk? Yeah? I call it the mother of object orientation, really. It is surprisingly like Ruby in what it does, but it did have a weird syntax. The book, Smalltalk, the language and its implementation, is really informative if you ever want to learn how MRI works. It's still very, very much how it's done. So the reason why I started with this compiling is of course that the current implementations have problems. And speed was the one that I always that I hit actually at the time when I started, because I bought a Pi, and Ruby turns your laptop into a Pi or a Pi into an Arduino, so speed is not okay, and I think it's the #1 reason why people don't use Ruby, because you get into this what's called the two-language problem, that you have to choose if you want nice or fast, nice being Ruby and fast being whatever Go and whatever. Okay. Actually, for me, the third point is almost the one that's most important, is that the Ruby implementation is not easily accessible to Rubyists. That I think is a real shame, and I'm hoping to change that. So the solution for all that is just to compile to binary and fix all three problems at the same time. And I don't know, how many did compiler courses in university here? I'll just go a little bit over what sort of compiling is, and what just to start with some syntax here, any program sort of takes some input, runs up, and produces output. So when the MRI runs, it actually takes our source code as input. With a hello world, it doesn't actually need other input, just produces output. So we think of Ruby and our source code as the program that runs. Even strictly speaking, Ruby is the program that runs. So this is called just runtime, whereas in compiling you have a compile time and a runtime. So here, if you compile with a CC, GCC or something, compile a hello world into an executable on the right, then you can take that executable, put it on a USB stick, send it to your friend. It's completely independent, and you can run it later, and it produces the output. So that is what RubyX is doing too, just for Ruby. So it's very, very similar. For example, you take a hello world RB and compile it to an executable, and that executable is just as independent as a C executable would be. So you can run it on a machine later or a different machine, and it'll produce its output. So that's sort of where I'm at the moment, and to get this behavior into the known behavior of Ruby, how we use it as only runtime, we would have to create a program like Ruby that behaves in the same way. That process is called bootstrapping, and the things one would need for that is to compile the compiler with itself. So that's the RubyX. You compile it with the RubyX compiler, which is basically the same thing, just run by MRI, let's say. And it creates a binary. The other thing you would need is the standard library and a complete core library, which you'll see later is I don't have yet. So if we had such a RubyX, then it would just work like MRI now. Take the input and your Ruby code, compile the Ruby code on the fly, and run it at the same time and produce the output. So that is the future, where this is going. So I'll go over what's actually working now. It's a fair amount, I think. That's why I wanted to present this, but it's nowhere near the whole thing. So the basic object-oriented stuff, I'll go over that a little bit more. Calling convention is sort of, I started implementing a calling convention relatively early on. It's not stack-based, so it's linked list-based. And of course, it uses objects. The whole system is just object-based. So it's much more easier to understand than any other, than C calling convention or stuff. Memory layout is pretty simple, but in place. And the main thing is, of course, we can actually create binaries. So just a little bit about the object model. In RubyX, everything really is an object. It's a little bit controversial choice, I think. Whereas in MRI, an object is actually an integer or an object, and you always have to test. In Ruby, actually, really, every object is the same. In RubyX, every object is the same. And the data is, as a consequence, opaque to Ruby, which it is pretty much to you anyway, but you really do not have access to data. You need built-in functions to process data, like an integer multiplication or stuff has to be coded in something else but Ruby. That's almost the same as it is now. So to implement a dynamic system, to compile a dynamic language, somehow one has to, well, the compiled code is of course static. So usually static languages have types to deal with that, to make sense of it. And a type really has to be immutable for it to make sense. So we have types in RubyX. They are just not classes. I'll go into that just a little bit. So every object has a type, and these do not change, but the reference itself may change. And that's how we implement classes. A class is implemented by a type at a certain time. And when you add, for example, an instance variable, we create a new type, and the class changes the type that it currently represents it. But the actual type, the previous type, does not change. So this distinction between classes and types, I think, is essential to get this thing done, and a major mistake in other implementations. So other things that are working are basic sort of control structures, if, else, whiles, without the fancy stuff. Assignments, local, and IVAR, and actually I forgot arguments too. There's no, I'll get to classes later. So I said I implemented the calling convention pretty early on, and static calling is relatively simple, like in the C version where you just pass, you just have to shovel the data over and transfer the control, and that's all done. The dynamic sending took me a little longer. It basically involves looking the method up at runtime and caching it. And Aaron Pedersen has done a nice talk about caching dynamic sending, the method, and has found that actually a cache of 1 is like good enough for 99%. So there's a cache in there, and it should be quite sufficient. So last year also that was relatively difficult. I implemented blocks. So the implicit blocks that you sort of pass to enumerators and whatnot. So it captures the block as an actual argument and passes the argument into the function, and then the yield is very much like a send, really, in that scope. And it's a sort of, and the return works with lambda style, so you return out of the block, not like procs. Okay, so blocks sort of work, but there's a whole list of things that really do not work, and I haven't even started on. Eval would be having to bootstrap the compiler and running the compiler at runtime. Procs binding, it's a whole lot of mechanics that is needed also for the exceptions. It's just I haven't got around to it mostly. Class methods I'm hoping to implement as the singleton methods on the class objects, so it's relatively easy. The standard lib out of these is I think the big one. Also the core lib that is not done. Okay, so I just want to very, very briefly to say how this is implemented. This is very sort of, compilers are very sort of top-down things where you work in layers and the data sort of trickles down. Ruby comes in at the top and binaries come out at the bottom. And I don't really want to go into this too much now, but just to mention that second but last, the risk abstraction it's the last sort of virtual layer in this compiler, where then the ARM is a sort of real, or the binary of concrete thing. When I started with this, I started and got things working. I had to debug binaries. That wasn't so much fun. So I wrote an interpreter for the risk layer, and after writing the interpreter, I made a graphical user interface for it. And rather than sort of show you hello world now on the command line, I thought I'll go through that a little bit, because the graphical thing is quite nice to see, I think. So the risk abstraction is basically the ARM with sensible names and just the stuff we need. So it's surprisingly little, I find. I mean, I've worked with the LLVM, which is like huge, and really we only need 20-ish instructions to implement the Ruby core, which is mostly about memory and access and register movements and a little bit conditionals and whatnot. So, like I said, I made a virtual, I made an interpreter for it and a visual debugger, which I wanted to quickly show you. You can look at it yourself on the website. If you go to architecture and debugger, there's a whole page on this, and you can play around with it. This is the page that you'll get there. I know you won't be able to see that so terribly well. I'll just show you. Here in the middle all the boxes are registers. Here on the left are the classes. And the nice thing is, because they're objects, we can just sort of look what's in them, you know, just recursive, which is nice. So there's a different, this is a debugging tool for me, basically, that it's different kind of preset code, source code here. And I've selected the hello world. And what it does now in the browser is actually compile this code into this risk layer. And then we can use these controls here to single step this code. So really, I only want you to see that things are happening on the screen here. So it's doing things. And then you can go quicker here, and whoop. And at each point, you could debug this and see what's going on. And here it says hello world, so it's done it. And that's all I wanted to show you. So that was hello world in RubyX. Thank you. Okay, just one slide about this project. So I've been at this for 4 years. A fair few commits there. I'm happy to say we have very good test coverage, really. I'm very much for tests. ARM binaries, like I said, are working, as is that interpreter, and executables are. And I had to experiment to get to this point where I am. So I think it's a relatively stable architecture now, and so that's why I'm presenting this. So there was a little bit of, whoa, how is this working going on? But I think it's pretty good now. So just yeah, the main basic idea behind this whole project for me is this microkernel idea. So I really want to make a small core and push everything out that isn't directly needed. So I use the bundler really as much as possible. So that's about it. I know it's just a start. You know, it's really very much. It's not nothing you can go and use now or something. But I think it shows that compiling Ruby into binaries is actually a feasible way, which is I think great to know. And most of all, I think this talk is supposed to be an invitation for you. Come and join the project, and we'll see where it goes. You know, it really. Yeah, there's the website and the GitHub organization. Okay, I think we have time for questions, if there are. We're out of time. Okay, so that clock there is something else. Okay. Well, just grab me later and ask your questions. Okay.
Hi. Thank you, Torsten. That was a very, very illuminating talk. We look forward to your alpha release at the 1.0 or wherever this ends up.